record and do this. Moment. Okay. Right. Okay, folks. So welcome back. We are going to continue on with the homework assignment, at least an example of the step 3 in the homework assignment, the reverse recode step 3. We will finish up with that. That homework assignment is due on Wednesday by class time. So I would like to, by class time, talk about some people's findings, what they did. If you can just share that with the class, that would be great. But for now, let's go ahead and get back into it. So again, if there is some issues with my screen freezing, somebody just wave or something like that, turn your microphone on and yell at me, hey, I can't see your screen, and I will try to adjust. So want to look back at the assignment. Okay, so this one is number 3. So I'm asking you to do a reverse recode on one variable. So sometimes you have variables that are coded in not a very intuitive way. So you might have a Likert type scale item that's coded as 1 being strongly agree, and then 5 being strongly, it should be 5 would be strongly disagree. And so that's kind of reversed. You would think the higher the score that someone has on that item, the more strongly they're endorsing that item. So how much do you agree with Biden's relief package, for instance? That oftentimes we would think, well, the highest score would be the strongest endorsement, like you strongly agree rather than strongly disagree. So sometimes reverse coding is helpful to make variables more intuitively interpretable. So you're not confused as to, wait, high scores are doing the opposite of what they thought they were doing. Well, that may be because your variable is coded in a non-intuitive way. And so recoding in reverse fashion is really easy to do. I'll show you one example, and then for your homework, you guys just have to find another variable and do the recode. Okay. So what we want to do, I'm going to go ahead and open up my Add Health screen. Can everybody see that Add Health screen? Yeah, okay, I see some people shaking their head yes. So, all right, so you should be able to see the Add Health screen. This is on the data view screen. And if recall, we can go down here, we can go to variable view, and this shows all the characteristics associated with a variable. The variable I'm going to examine for this particular step is it's H1PF1. H1PF1, I could just actually do this the easy way, Control F, and just type in H1PF1, and then goes down to that. Okay, and now, the variable names and a lot of data sets, they don't tell you really anything about how the variable itself is measured. It's coded in some way just to make it a unique identifier. But this is a question, I believe if you go back to the original survey and you have access to that, I believe it asked if they felt that their mother was warm and loving. Okay, so this is a question. There's all kinds of parental-child relationship type questions in this data set. So here's one of them, and this is how they coded it. Remember, under the values column, it shows you how data were coded. And it has this situation where you've got a Likert type item, but it is not coded in an intuitive way. It's reversed. So you've got 1 being the strongest endorsement of that item, and then a 5 being you're not endorsing at all. It's strongly disagree that there is something horrible has gone on in this household, I guess, for people to say they strongly disagree, or they just hate their mother that day. I don't know. But anyway, sometimes this is not too helpful to have things coded like this. It seems to me, in my mind, this is just backwards, that a higher score should be stronger endorsement, especially of a Likert type style item. And so what we want to do is we want to flip this. So we have a reverse coding situation. So we have basically the 1 becomes the 5, the 2 becomes a 4. And because 3 is right in the middle, there's a 1, 2, 3, 4, 5 level. There's a odd number. 3 stays a 3 because it's right in the middle of the distribution. That does not change. So we want to recode this so that a 1's a 5, a 2's a 4, and 3 stays a 3, and then keep everything missing. Okay. And so at any point, just yell at me or shake your hand furiously at the screen, and I should be able to see you, and I will stop. But what we want to do here is, okay, so our job here is we want to reverse recode this thing. So we go up to where it says transform, right up here, transform, and we want to recode into different variable. Oftentimes you do want to do recode into different variable, because if you don't, it will overwrite the original variable. Not that it's a big deal in this case, because you can always open up the data set again and it's refreshed and it's the original data set. But just for future reference, whenever you guys are doing any sort of data analyses and using SPSS, it's usually the safe bet is just to not rewrite your original variable, recode into different variables. So you click this one, and then we have to find that variable. It is H1 PF1, and I always like to right click on this and display variable names, right click again and sort by alphabetical. And then you go H1 PF1, find that, and oops, sometimes I skip over it, H1 PF1. Usually these are in alphanumeric order, but sometimes not. There it is, okay. All right, and so we can call this, see, warm and loving. Oops, we have to put, I'm going to put underscores between here. We can't have, if you recall, we cannot have spaces. It's very sensitive on the spacing. So I put underscores in there. It should be okay. And then, see, we can do reverse recode of warm and loving variable. Okay. Okay, and then we hit change. Oops, I got illegal characters. What's illegal? Let's see here. Let me do this again. Warm and underscore loving. Did I put a space? I may have put a space in there on accident. Okay, yeah. If I hit space bar after the G and loving, then it would not let me do that. Okay, so yeah, you always want to hit change before you go into this old new value box. Otherwise, it won't let you go into the old new value box. All right, so old new values, right. So what we want to go ahead and do is we want to reverse recode this thing. So if you had a 1 on the original, now you're going to have a 5 on the new variable. Add, okay, and then it puts that over there. 1s go to 5s. 2s then would be 4s. Add. And then 3s would stay 3s. Add. And so this is, yeah, this is right. Okay, the one more thing we want to do, see, 1 to 5, 2 to 4, 3 to 3, right. Okay, so that should take care of, then I don't think we have to do 4 to 2 and then 1 to 5. I don't believe so. I don't believe we have to do this, but we'll find out real fast, real soon here if you had to do that. I don't believe so. But what you want to do though is we want to account again for, there are some respondents for whatever reason did not provide valid responses, and so you always want to click, if you want to leave these people missing in your new variable, you want to click this the second button down here, system or user missing, and then you say, okay, if you're missing on my original variable, you're going to be missing on this new variable too. Sorry, but we just can't use you in our analyses because you're missing information. And add, and then we should go ahead and okay, so that looks good. Hit continue. And hit OK. And let me stop sharing that real quick and let me go back to this screen, because I think what I want to do now is I want to go ahead and run my frequency table on this recoded variable. So I want to go to Analyze. I want to go to Descriptive Stats, Frequencies. And the last variable made will always be, initially, at least if you don't mess around with the alphabetical order stuff, will be the last variable that appears in your data set. So here we go, the reverse recode. We want to go ahead and run that. and we don't need to mess with any of these other buttons over here just yet. Go ahead and hit OK. And okay, so I did make a mistake. What we have to do is we will want to recode it so that it reads 5 to 1, also 1 to 5. So I'm glad I made that mistake. What I'm going to go back and do, so if you ever make a mistake with this, by the way, is that froze? Can you see this output, folks? Can you see this? No? Okay. Let me go back. Yeah, this is terribly annoying when this does this. Okay, so you notice here, where'd my 1 and 2 go? Well, I didn't do the reverse coding correctly. So I'm glad I made that mistake, because I can show you what happens when you make a mistake and why it's really important to run your frequencies to make sure that you have all the original people accounted for, because we've lost our 1s and 2s. And so that's a problem. Whenever that happens, you run your frequencies, you'll see you made a mistake. You can just go back here. Can you see this screen? Can you see I'm moving up and down? No, okay. Stop sharing. Go back to this. Okay, so you should be able to see it now, right? Yeah, what I'm doing. Okay, so I want to go back. I'm just gonna erase my mistake, and I want to go ahead and just, click on this. So it's yellow. Right click and clear. All right, so let's start that again. All right, so let's just go back, recode into different variables. Okay. So can you see this screen? Can everybody still? Okay, so let's go back in here, old new values. All right, so let me, I'm going to remove this missing sys thing for a second. I'll put that back in there. So let's go ahead and the coding code is slightly different from software to software. Another software program, it would have understood what I meant by, it would be understood. I didn't have to repeat this. But for SPSS, let's go ahead and then continue the sequence. So we want to go then, okay, we want to go 4 then is 2. And then we want to finish it off, 5 is 1. All right. So, and then we don't want to forget about our missing people. And so system or user missing, now system missing. Okay, so if you're missing on the old, you'll be missing on the new. Right, okay, so this should be correct. If it's incorrect, then I don't know what the heck is going on. So this should do it. So 1s now become 5s, 2 becomes 4s, 3 because they're exactly in the middle of the distribution. There's a even number of, or an odd number of levels to this variable. 3 stays 3. Okay, 4 goes to 2 and 5 goes to 1. All right, so this should totally reverse code everything. Go ahead and hit OK, or continue and hit OK. All righty. Now, okay, so this is our mess up. Now, let me, I know you guys, I just realized you probably can't see that. Let me stop sharing again. Let's go back to the screen. Okay, so let me go back to here. So we're going to go ahead and analyze our variable. It should be correct now. Let's make sure. Okay, we're going to go back. Here's the reverse recode. I'm going to put that over there and hit OK. Yay. Okay, so we see down, you guys probably can't see that. Why is he saying yay? All right, so let me go back to this. Okay, so can you see down here now? Can you see at the bottom? The bottom of my screen. Now we have 1, 2, 3, 4, 5 all represented, and it is this should be the total flip of the original variable. So in order to check our work, first, can we see this output? Somebody shake their head if we can see. Okay, yeah, I see Matt shaking his head. Great. Okay. So you can see that output. We want to check, we can easily check our work by analyzing the original variable to make sure it's an exact reverse recode of that original variable. So the original variable is H1PF1. So let's go back to descriptive stats, frequencies. We can just reset this to get rid of that. And then we want to go display variable names, sort alphabetically, H1PF1. Oh, come on. just missed him. Okay. There, where is our guy? There he is. Okay. And we hit okay. Right. Okay. So can everybody see that there at the bottom where it says, oh, mom, warm and loving? Can we see that? Okay, so we can check our work now. So so this is the strongly disagree. Only 6 to 1 people disagreed that their mom is warm and loving. So that's at the top of the scale. And our recoded one, 61L, is at the bottom of the scale. See that? Okay, so everything now lines up. 175 who disagree with it. Now they're down. Now they're at a 2. And the ones that are neutral, they're just not sure about mom. That's 326. Same thing here in the middle of the scale, 326. And the 2,404. This is okay in the reverse spot down here, 2,404. And where the majority, the modal category for this would be, because it's the most popular response given, would be, yes, I strongly agree my mom is warm and loving. So that's 3,153, and that's the highest score on our reverse coded item, 3,153, and we've got the same number of missing. We've got 385, and this is a breakdown down here of the number of people missing. 6 just refused. 370 legitimate skip because they have no relationship with their mom, and 9 don't know, and those add up to 385. Okay, so that is what you have to do for step 3 of your homework. You can't use the example I gave. Just sort through there, or look through the Ad Health data set on variable view, find a variable that to you could use a recoding, reverse recoding, that is, because it may be in a Likert type scale, but it's backwards, because I think it's just in my brain, I'm just not smart enough. I don't know, when I see something that's backwards like that, I can't deal with it, and I have to recode it so that the higher score means a stronger endorsement of the item. This is going to make a lot more sense when we get into the higher level stuff, when you're looking at things like regression and correlation analyses, because if you don't reverse recode stuff, you'll get correlations that are the opposite sign. They'll be negative and you really think they should be positive. And then you have to remember, oh yeah, it's reverse coded. It's not coded in an intuitive way. That's why the sign is reversed on my correlation matrix or my regression beta estimates. So, you might be thinking, well, I can plainly see how it's coded. But when you get past these univariate stuff, past this descriptive stuff, and you're into bivariate and multivariate analysis, that's when it really pays off to do the work ahead of time and recode this stuff so you don't confuse the hell out of yourself later on by forgetting to reverse code stuff, because it becomes much more intuitive. Statistics become a lot easier so long as there's an intuitive interpretation to them. You get, and it really helps when you do the recodes to make it more intuitive. Okay, are there any questions about this, about what we did, about any of this recode stuff, about the reverse recoding? If there is, shoot me an email. If you can't think of your question right now, I can get on and try to help you out remotely. But yeah, that's that for this assignment. Okay, so what we'll do now is I want to talk to you about another type of coding exercise that you can do in SPSS, and this is computing new variables. So a person might want to create a new variable out of existing information that may be contained across multiple variables. You may want to create, like what we're going to do right now is we're going to create a scale of BMI, body mass index. That is created from combining a person's weight divided by their height squared. So this is a very useful statistic for anybody in health research. It's not only physicians that are into this, but sociologists that are into the sociology of health. BMI is one of these core sort of physical stats that people will look at. And there's much more sophisticated ways of calculating BMI that accounts for your gender and accounts for your age. We're going to do the really basic one that people sometimes complain about that is not accurate, but we're just going to use the simpler one for class a day. But in order to get there, it is going to take a couple steps. And so just recall this video is being recorded, and you can always go back and watch it in case you're like, he's going too fast or something like that. Again, if there's something that you need me to slow down, just yell at me or wave furiously at the screen and I will stop. But what we want to do is we want to make body mass index as a variable in the data set. So what we want to do is, let's go back to our variable view, and we want to look up the variables involved in this, which is height and weight. All right. So if we the first height variables, it's H1 GH59A. I'm going to find that the quick way. Control F, and I'm going to go to H1 GH. Oops, GH doesn't matter if it's lowercase. I don't think 59A. Okay, find that. Okay, so here it is. Now, here it is. This is height in feet. Now, for whatever reason, they divided height as measured in how many feet tall you are. So you have, okay, 4 foot, 5 foot, 6 foot, and then they measured inches in a separate variable. So here's inches, and it doesn't, it tells you, so all the way from 0 inches. So somebody could have a score of 5 and then a 0 on the inch variable for inches, and so they're 5 foot even. And so it's really whatever your feet is plus whatever your inches is on this, and that's how you get to feet and inches. But we want to make the variable so that it's your total height measured in inches. We don't want to have two separate variables, one measuring your height, one measuring your height in feet, and one measuring your height in inches. We want it all together, so you have a height of whatever 66 inches or something like that. So what we want to do here is we want to convert the height and feet variables into inches. All right, so in order to do that, in order to take this variable and convert it into a variable that would be mathematically usable for our purposes of making a BMI variable later on here, we want to go to where it says, okay, up here where it says transform, go to transform. Now we're going to go to where it says compute variable, the very top one, compute variable with a little computer icon or calculator icon right there. So let's go ahead and when this screen comes up, okay, before I get into this any further, where it says target variable here, this is actually, I'm not sure why it's called target variable. It's not very helpful calling it that. That is just the name of your new variable. So whatever you're going to call your new variable, that's where you type in here. So this is a variable name slot. So that means it follows the rules of the variable name. So they can't have spaces in them. They can't be very long. And so we're going to call this something that is easy to understand what we're doing. We're going to call it feet _ to _ inches. Feet to inches. Okay, so we want to make a variable called feet to inches, and we want to convert the variable that is measuring your feet in your height in feet to inches. And so what we want to do, I want to go ahead and display variable names, sort alphabetically, and it's the H1GH59A. So H1. Oops, I know my alphabet. Nope, I don't. Okay, here we go. 59A. So remember, this is measuring your height in feet. Okay, if we convert that to inches, remember there are 12 inches in a foot. And so what we got to do is we just click on that. We want to send that over there by clicking that middle button. And then this is just a calculator. The center part, you can use your keyboard to do this too, but here's the little star, that's for multiply. So we want to multiply it by the constant of 12 to represent 12 inches in a foot. So everybody's foot score is going to be multiplied by 12. So it's essentially going to convert the feet into an inch measure. All right. So so we named our variable, new variable, feet to inches. We had to find the original variable over here that was measuring your height in feet, and we add that over there, and then we're multiplying it by 12. All right. So we go ahead and hit OK. And now I know my screen is probably froze, but that's OK. I'm going to go back. I'm going to stop sharing, and I want to check my work. So what you want to do is go back into this, and we want to, first, we can just scroll down to the bottom of this, and we can see our variable appear at the very bottom. Okay, yeah, feet to inch. We don't need to mess around with the label or anything with that right now. We just want to oops, never mind. We want to just go up here, analyze, and go ahead and run a frequency table on this and see if this makes sense. See if we did this right. If you're getting scores like 3,000 inches, like that doesn't make any sense. Wait, where's our display? Where is it? Did I? Oh, duh. File order. You have sort by file. If you sort by file order, it'll always be the last one down there. Okay, feet to inches. Put that over there, and going to hit and hit OK. Okay, good. Now let me. I know you guys can't see that. Just a second. Wish it would not do that, but I can't do anything about that. Okay, now going back in. Okay, so now we can see, let me get this up here. So down here, this is this feet to inches variable. And so instead of a 4 foot, 48, instead of 5, 60, instead of 6, 72 inches. Okay, so now we're good to go with that variable. So we've got our feet measured. I'm sorry, feet converted to inches, right? So now what we have to do, we have to add feet to inches to the variable that's measuring the remainder of the height in inches. And so in order to do that, we want to go back into where it says transform and compute variable again. Okay, go ahead. When you go back into these screens, it's always going to save or retain whatever you did in the previous step. So it's going to have all the same stuff in there. So I usually just like to start with a blank slate, reset. You reset it and clears it all out. And so we want to convert the variable. Well, we don't have to convert anything yet. I misspoke. We want to add in the height variable that was measuring the remainder of height in inches, and we want to add that to our feet to inches variable. So what we want to do here is we want to we'll call this new variable feet underscore in underscore inches. Okay, so our target here is to create a variable that measures your total height in inches. So in order to do that, we say, okay, so the first thing we want to do, I want to go down and find my recoded feet variable to inches, put that over there. And to that, we want to add the remainder, the inches. And so we hit the plus sign here. So it's going to be adding. Okay, and then we want to go and find that variable that was measuring height in inches, and that is, or the remainder of the person's height in inches, and that variable is H1GH59B. All right, so I'm going to display variable names, and I want to sort alphabetically, and I want to go into where it says H1GH59B. Okay, and put that over there. So, okay, so what it's saying, I'm telling the computer, all right, I want a variable, we're going to call it feet in inches, and I want to take my converted foot measure that was measuring just my total number of feet I am, that was converted in inches, and I want to add the remainder, however more inches I am that past 5 foot, for instance, and add that to the variable. So we'll get a total measure of one's height, their from those two other variables measured here in inches. Okay, so we do that, we hit OK. All right, and let me go back, and we should then get a variable and go back into the screen. Okay, we'll go up to here, analyze descriptive statistics. Going to reset that and then just go down to the bottom, feet in inches, put that over there in the box you want to analyze and hit OK. Right. Okay, so can everybody see this screen right now? All right, so yeah, at the top you say feet in inches. Okay, and we have two people that were 48 inches, and then one person who is a giant, and I'm assuming he is 81 inches tall. So I'm where am I? I'm 70. I'm 6'1". I'm 73 inches, and so yeah. So this is and so the what I also wanted to do with this I forgot. So here's our basic frequency table, and so recall here is the first column. This is measuring the frequency, the number of people. For instance, 48-inch people, the number of 48-inch people in the data set, there's two of them. The number of people who are exactly 5 foot, right, there's 237 of them. Okay, so here's the frequency. Here's the percent for the frequency. And here, over here is what's called the valid percent. And so it's actually, in this case, it's identical because we don't have any. We have, well, it's going to be slightly off. I misspoke. It's going to be slightly off in some cases, like right here. It's going to be slightly off because the valid percent is taking the percent out of, not out of 600, 5,004, but it's taking it out of a total of 6,408. So the valid percent, the denominator is always going to be the total number of cases that have non-missing values for that particular variable. So it will be slightly different if you have a relatively small number of missing cases right here out of 6,504. That's a relatively small. It's only 1.5% of the cases missing. So the percent and valid percent columns are pretty similar. And then over here, it's giving you again the cumulative percent. So it's just this plus the next one plus the next one, and it'll always total up to 100%. So that's what the cumulative percent is. All right, so there's that. And the other thing that we can do here is, in addition just to running the frequency table, if you go to analyze and go to descriptive stats and go to frequencies, in addition to that, we can also go over here to statistics. And so this is an important button in this screen. It's an important button because when you click on it, it brings up all your measures of central tendency that we briefly went over in the previous class. We're going to go over this stuff again. But we can say, okay, in addition to the frequency table, I want the mean. Remember, the mean is the same thing as the average. It's the average score. We also can get the median. The median, remember, is the exact middle score that divides the distribution about 50-50. The mode is the most popular score, the most popular response given. And it's possible to have two modes if there are two most popular given responses. We don't care about the sum for this. That's just not something that we need to worry about. Down here, though, we also usually want to, when you're reporting descriptive stats, don't click the range. You actually want to click where it says minimum and maximum. So that's going to give you the minimum score. In this case, it would be 48 inches, and it's also going to show you the maximum score, which is the giant, the 81 inches. Okay, so we're going to get the min and max. We want that, and that's considered. Usually, people call that just the range, but in SPSS, if you request range, it takes the minimum score, subtracts it from the maximum score. So that's not too terribly useful. The other thing is that we want to click under these measures of dispersion. We want to click the STD dot deviation. So that stands for standard deviation. Recall, standard deviation is the average distance from the average. Because if I were to measure everybody's height in this class in inches, and I gave you the average, no one would actually have the average score. You would all vary around the score. And so the standard deviation is the average variance around that score. Okay, the average distance from that score. and we go ahead then and hit continue. Or let me also then go into charts. Charts is not quite as important as the statistics button, but is where you can make some charts. And what we want to do is we want to go and hit where it says, click where it says histogram. I don't think I have you do this on your homework, but I'm just going to show you how you can produce a histogram. And then we can also click down here where it says normal curve on the histogram. That shows you where the bell curve would be drawn, because the bell curve is assuming that you have a symmetrical distribution, and that the measure of central tendency really is in the center of the distribution, so you get this bell curve type shape. All right, so we go ahead and hit continue and hit OK. And it's doing it, I think. Yeah, processing. All right, here we go. Okay, so here are our stats. Okay, can people see this? Can we see? I'm circling. I'm making my thing go in circles. Right. Okay, so here it's always going to give you. Here's a statistics box up here. Here's where I see. Here's our mean. So the average height 68.2484 inches. Median height 66 inches divides the sample in half approximately. It's not quite a normal distribution. You'll see below. So that you can't really say that's 50-50 really. But then the most commonly given response is 64 inches, so 5'4". Deviation, standard deviation here. So the average person is 4.12 inches away from the average, either above or below. Okay, so the average person deviates from that average by about 4 inches. Okay, so our minimum score, the shortest person in our data set is 48 inches. Our tallest person is 81 inches. Okay, so that's all our descriptive stats right there. And here it gives it the valid number of cases. Remember, in statistics, usually almost always indicates the number of observations. So we have 6,408 observations here, and then we have 96 that are missing. Okay. Below that, here is our nice pretty histogram. And so here it is, it's almost a normal curve. You can see where the actual observations do sort of peak out above where the curve is, and there's a little bit of it coming out here on the edges, but it does follow pretty much the often observed so-called Gaussian or bell curve. And so you've got the bulk of the people are somewhere in the mid 60-inch range. They're 5-something. We've got a shrinking, rapidly diminishing number of people who are way far out there on the right tail. And over here, these are called the tails. Statisticians call these the tails. So here's like the bulk or the body of the distribution. Over here, here's the right tail. So these are the high end of the scale. So remember, we've got somebody that's 81 inches. And then here is the left tail. And so this is where you have a rapidly diminishing number of people who are below 5 foot. Okay, and so that's called the normal curve, and it's assumed, we'll get into this later, that when you you take a sample, that even though individual measures in your sample may not be normally distributed, it's assumed that the sampling distribution will always be normally distributed. That means if you take hundreds of samples, the average for each one of those samples is going to vary a little bit. But then if you plot the averages for all your samples, they themselves will form a bell curve. Okay, so that's a kind of a law of statistics. It's kind of magical. That tends to happen. There are some cases where it doesn't, but the sampling distribution is always assumed to be form this bell curve, even though if individual measures don't necessarily form a bell curve distribution, because some definitely don't. Some follow more of what's called a power law distribution. So something for another class. Okay, so we got this. So far, so good. Now what we want to do then is let's also take a look at the weight variable. And we don't have to do any conversions with the weight because the weight's measured in pounds. We're going to go to descriptive stats, frequencies, and let's just put this feet to inches back over here. And we want to go to where it says weight is H1GH60. So display variable names, and I want to sort alphabetically. So weight measured in pounds is H1GH60. Oops. Right there. Okay. And so H1GH60 is its weight measured in pounds. I didn't go to the variable view, but trust me, it is. I checked it right before we did this. So this is I'm going to go ahead and just run the frequency on this, and just to show you this again, the output that you get. So this is weight measured in pounds. So yeah, believe it or not, there's somebody who says that they are 50 pounds in this data set. Small person, and then we have the full range of weight. So it goes from, so here's the lightest person is 50 pounds, the heaviest person is 360 pounds. The average weight in our sample is 141 pounds, 0.07. This is sophomores in high school. Okay, so yeah, so you're going to have a lighter people in this data set. So that's why the average is kind of low. Median 135 pounds. And the mode is 120. So that little A next to it shows there are multiple modes. So there must be some weight that has more that's matched in the number of responses. So 120 is one of them, and there must be another weight category that more than one person had the exact same weight. And so you could look through there and find that which one is the exact same as the number of people who gave 120 as their answer to this. But so anyway, this is weight, and we can go down here and look at weight, and it's what's called slightly right skewed. This is called a slightly right skewed distribution because the tail, it's got a bigger right tail, or the tail on the positive side of the distribution, or the right hand side it's kind of like, you see, it's like kind of being pulled this way, which means that there is proportionally more people who are average or below average weight than there are people who are really heavy. Again, these are sophomores in high school, so you're not going to expect a lot of dudes in here that are 250 pounds. You don't get that until you get into college usually. So, so that's called a right skew distribution. It's when it's the tail. There's a disproportionate amount of people on the right hand side of the distribution. So a diminishing number of people on the very high end of your scale. All right. So, but okay. So. Time's getting limited here for this class. So I want to go in and finally want to go into compute variable and make a BMI. All right, so we want to go ahead and reset this. Can everybody see this screen, the box that popped up? Okay, so target variable, we're going to call this BMI, stands for body mass index. All right, so the way we want to do this is we want to say, okay, this is going to be, like it says, set equal to parentheses. And well, let me just, before, because that's going to mess it up, I just want to exit out of this. Let's find the variable for weight. And so we want to put, it's weight divided by height squared times this constant of 703. So we just have to follow the formula. So we want to go to, outside alphabetically, we want to go to our weight variable. So H1GH60. Okay, H1. Come on, where you at? Okay, H1GX60. Okay, and remember, we want to make sure that our order of operations are being done in the right order. So put that in parentheses. Okay, and then we want to have this being divided by height measured in inches squared. So we want to put another parentheses in there. And, or wait a second, let me do this. I'm just gonna put the parentheses in later because it's just gonna erase it. Okay, I'm gonna put this over there. This will be easier. So we're gonna just grab our two variables first. Grab this, and then, oops, display file order. I'm just looking for our height in inches variable that we made earlier. Okay, put that over there. All right, now I'm going to start putting my parentheses in because otherwise would not put it in the right place. Okay, so we want to put that in there, this in parentheses. That is divided by this, and we have to actually multiply it by this again. Okay, it did put it right over there. So there's a couple different ways to make it say squared, but this is just height, feet in inches times feet in inches. Okay, so I wanted to do that in parentheses. Okay, and then I want to, then it's to get it the most basic measure of BMI, then you want to have this multiplied by the constant 703. Okay, so we got weight measured in pounds divided by feet measured in inches squared times 703. Okay, so this should work. Go ahead and hit OK. All right, so okay, so it always, remember this, it's always going to give you a little bit of the syntax of what you did there. And again, we want to go up and make sure this makes sense. So there's a standardized range for BMI, and we'll know right away if we did this right or not, because we don't want anything way outside of the norm. So BMI is between 18 to 40 something is what we should be expecting. You're below 18.5 means you're underweight. If you're above 40, it means morbidly obese. So let's, and most people are somewhere between like 18.5 and 20 something. Well, anyway, that's said to be healthy. So let's file order, just trying to find this variable, BMI, send that over there, hit OK. Right, okay, so we've got the BMI, average BMI, 22.46. That sounds about right for high schoolers. Median is 21, mode is 19, standard deviation is 4.41. Smallest BMI, 11.21. That's probably that person in there that was very short. And then you have, then we got a heavy hitter here, 56.38. Okay, so here, and you can see the full range of the BMI. And so it goes from whatever it says, 11 something, all the way down to, actually, let me go over, can we page down on the screen? Yeah. Okay, yeah, and so we get down to here a person who is BMI 56.38. And so we have, and here is our histogram again. And again, this is a little right skewed because this tail is disproportionately big. And this is large part because these are relatively young people. You're not going to have a lot of bigger people in this data set because it's high school kids. But this is showing your BMI, and so that's how you make a BMI, and more generally, that's how you compute variables using 1, 2, 3, or multiple variables that are already created in your data set. Okay, folks, so that is all for today. Remember, your homework that was the reverse recode is due by class time on Wednesday. We will just continue on. Make sure that you've read the SPSS book, the stuff on descriptive statistics, by Wednesday. We'll get more on descriptive stats, and then we will maybe do one more of these exercises, and then we'll get into something called Z-scores. Not too much with that, but we'll touch upon that, and that will be it. All right, if there's anything at all, you can stick around. I'll stick around for a little bit and talk with you, but that is it for today's class. All righty, you are free to go unless you want to stick around and ask me some questions. Bye.